Hey guys, welcome to section 3 of chapter 7 of the pre-algebra program. And in this section, we are going to work on our inequalities. We are going to specifically test values to see if they are true or false. We're going to graph inequalities, and we're also going to write inequalities. So a couple of fun things. I'm not sure, again, if you've had any experience with inequalities. If this is your first go, they're not terribly difficult. So hopefully you'll be able to catch on pretty quickly. So first, let me draw your attention to what is different about a problem like this than the problems that we have been working on previously. So an inequality is an expression with this sign. It's the greater than or less than, greater than or equal to sign, or less than or equal to sign. Those are the things that make an expression an inequality versus an equation. So an equation contains an equal sign, but an inequality contains one of these following signs: greater than, less than, greater than or equal to, or less than or equal to. Remember that the bar on the bottom means we want to include that number. So that's why we say greater than or equal to, or less than or equal to. So take a note, in all of our problems that we're going to do in today's assignment, we are not going to have equal signs. We're going to have these inequalities in our expressions. Okay, and what that means is that we're going to get an expression for an answer as opposed to a single number. So again, in all of the problems that we've done thus far, in the end, we'd get something like x equals 2. We get one number and we could test it and it makes us happy. But in these problems, we're going to end up getting something like x is greater than or equal to 2. And then we're going to test to see if that value is true. So that's what we're going to do to start off here. So we have the expression 5 is greater than or equal to 2t minus 12. And we want to know, is this true when t equals 11? So we're going to do our substitution, which we've had lots of practice at. Hopefully you're feeling very comfortable with substitution. We're going to go ahead and make the substitution for t. And we're going to be very careful with our order of operations. And we're going to make sure that we multiply this first, which is 22, before we subtract. And 22 minus 12 is 10. And the question is this expression true? And we always read left to right, so we ask ourselves, is 5 greater than or equal to 10? And of course the answer is no. It is not. 5 is not greater than or equal to 10. So the answer for this type of question then, of course, would just be no. Okay, let's do another one. What if we had 6r minus 18 greater than 0 when r is equal to 3? Okay, we're going to go ahead and do our substitution. So for r, I'm going to write 3. And keep everything else the same. Make sure that we do the multiplication first before subtraction. And then we're going to go ahead and subtract. 18 minus 18 is 0. Now, be very careful. A lot of students will be tempted to say, yes, this is true. They are the same on both sides. But this sign is not an equal to sign. And notice it is specifically missing the bar on the bottom, which would denote an equal to sign. So we would strictly read 0 is greater than 0. And that is not true. So our answer for this one is no, because there is no bar underneath this equal to sign. If there had been a bar here, then the answer would have been yes. But it's not. So we have to remember, you got to be very careful with that little bar there and pay attention to whether the expression is true or false. Let's just do one more of this kind. 3n plus 2 is less than 26 when n is equal to 3. Let's go ahead and make the substitution. Make sure you multiply first and then add. And then we ask ourselves, is 11 less than 26? And of course, the answer for this one is yes. 11 is less than 26. Okay, so I hope that that makes sense. The methodology of these is exactly like the substitution we had been doing in previous chapters with our equations. The only difference here is this bottom line, where we're not testing to see if they're the same on both sides. We're testing to see if the expression that we get at the end is true. All right, so let's jump into some graphing inequalities. What if I had something like x is greater than or equal to 4? We're going to use number lines to graph these, which is fun. We haven't seen a number line in a while. So go ahead and make sure that you make yourself a number line in your notes. In fact, if you stop and make like a really nice one and maybe get a bunch of different colors, you can do all three of these examples on the same number line. That could be fun. Okay, so what happens when x is greater than or equal to 4? Well, make sure that you start with whatever number that you see here. We're going to start at 4. So I'm going to go over here and find 4 on the number line. And we have two things that we're looking for. The first is, why? I don't know why that always comes up. Is whether the circle is going to be open or closed at the number. So we have an open circle if it's strictly less than or greater than. But we have a closed circle if it's less than or equal to or greater than and equal to. So we have to pay attention to the sign in the expression, and in this case, we have a greater than or equal to, which tells me I'm going to need a closed circle at 4. So this is kind of your first step, identify your circle. And then the second step is to ask, which way for the arrow? If it's greater than, we go to the right. And if it's less than, we're going to go to the left. So in this case, x is greater than 4, which means we want all of the values that are bigger than 4 for this expression. So we have a closed circle because it's equal to, and we have an arrow pointing towards the right because we want all of the values greater than 4 for this expression. Okay, let's do another one. I think I might change colors here. What if I had x is less than -2? I'm going to draw myself another number line here. If you stopped and made yourself a nice one, good for you. That's probably what I would do if I were taking notes. Okay, so the first step was to identify the sign so we know what kind of hole or dot we need at our number. And in this case, we have strictly less than, which means we need an open circle at -2, not a closed circle, an open circle, because we don't want to include the value of -2 in our answer, in our solution set. So we don't want 2, we want everything up until 2. So we have an open circle. And then which direction should our arrow go? If it's less than, we go left, and if it's greater than, we go right. But in this case, it's x less than -2. And so we're going to go left here. All right, let's do one more example. These really aren't too bad once you kind of get the gist of them. What if m is just less than 0? Notice here we check our sign. There's no equal to, so my circle must be open here at 0. And it's less than 0. Less than values are always to the left. We want all the values less than 0, so we want our arrow pointing left. All right, that's it for graphing the inequalities. So that's pretty painless, I think. And then there's one other piece to this. You have a couple of story problems. I wanted to do an example or two to help you learn just how we might translate a sentence into an inequality. So if I had something like, at least 300 students attend Maple Crest Elementary school, we'll say. How would we write that as an inequality? So at least means we can include the 300. So let's let our value be S for our students. And there's at least 300, so there could be more than that, which means the number of students has to be greater than or equal to 300. So it could be 400, it could be 500, it could be 1,000, but it's at least 300. So this is the expression that we're looking for if you need to write an inequality from some wording there. Let's do one more quick one. You only have a couple of these, but I think that they're worth kind of playing around with. An electric bill increases by $15 and is now more than $80. All right, my key words here are more than. So before it was at least, meaning it could be the number, but now I'm strictly more than 80. And what is more than 80? Well, whatever our electric bill was, plus 15. It was a bill plus 15, and now it's more than 80. And so this would be the expression that we were looking for this one. Okay, you guys, go ahead and finish up your notes, read through the section, copy down examples if you need them, and begin your assignment.